video will introduce us to some of the key properties of exponents, the multiplication properties, and what to do with zero and negative exponents. Now, before we get started with this, I want to point out that what we're working with are things that are to a power. So, for instance, we could have x squared, and what x squared means is that we have two x's being multiplied together, or we could have 3 to the 5th power. And 3 to the 5th power means that we have 5 different times being multiplied together. And what the exponent allows us to do, if it's a number or a letter, either way, is just to represent it in a more condensed manner. So what we're going to look at is these rules that will help us to simplify expressions, and it will really become beneficial to us in later math where we're doing other things. We'll start to use these rules without even really thinking about the fact that they're rules that we had to learn in the first place. So our first rule is product of powers. And an example of this is saying x squared times x to the 4th power. Well, if we think about this like what x squared is and what x to the 4th is, x squared has 2 x's multiplied together, and x to the 4th has 4 of them multiplied together. And so if we wanted to combine this together, if we wanted to simplify it so that there was just a single x to represent all of these, there are actually 2 here and 4 here, which together make 6. So x squared times x to the 4th is x to the 6th power. Now, we did that just now by looking at these expanded, but think about what we could do now that we know that the answer is x to the 6th. How do I get 6 from these two numbers? I get it by adding together. So the rule for product of powers is if I have two things with the same base, so both of these were x's, or they both could be 2's, or they both could be y's, or whatever, then if we're multiplying them together, I just need to add their exponents. So this would be x. For our rule, we'd write this mathematically as x to the a plus b, which just lets us know that, hey, these exponents get added together. Next rule is power of a power. So we have x squared again, but this time we're raising the x squared to the 4th power. Well, what that means is that we've got x squared being multiplied together 4 times, because that 4th power tells us to repeat what's inside that many times. Well, if I have x squared, I have it 4 times, we could go even further and write them all out as x's. But now that we know the product of powers rule, let's just add the exponents together. 2, 4, 6, 8. Who do we appreciate? Anyway, this would be x to the 8th. So now let's look at these exponents and figure out how we could come up with that without having to write it all out. 2 and 4, to get 8, you have to multiply. So if I have something that's to a power and it's raised to another power, what I do is I multiply those exponents together. And you can write this either with a times b using a dot, or you could just write the a and the b right next to each other. Both of those signify that we are multiplying, so whichever way you want to write it. Power of a product. What this says is that inside of my parentheses here, I have a product. This is not a plus sign, because a plus sign would cause a very different situation here, one that we are not actually prepared to deal with at this point in Algebra 1. But if this is a multiplication symbol, and I've got this cubed here, what's happening is, well, we really don't need that multiplication symbol there. What's happening is that we have xy, and we have it 3 times. And so to combine these together, I would say, well, how many x's do I have? I have 3 of them. How many y's do I have? I have 3 of them. So this simplifies to be x cubed, y cubed. Now think about what we basically just did here. We ended up giving both things that were inside of our parentheses the power that was outside. They already have powers technically of 1. Okay, and so we actually were multiplying 1 times 3 for each of these, and that's how we got x cubed and y cubed. So the rule is that whatever is inside, if it's all multiplication, we're going to give everything inside the power that's on the outside. So this would be x to the a and y to the a. Now, these rules here on the side, by the way, this may seem weird to you that we have just all letters and no numbers, but that's pretty typical in math, that when we want to actually write out a rule, we want to write it so that these letters A and B can be anything we want, or even X can be anything we want and have it still be true. So that's why we're not writing a rule like the examples in the middle here where there's numbers. We're writing a rule where all of our important things are variables. Our next rule is an interesting one. We have the zero power, and we have to figure out what that means. And then if you look ahead, we have negative powers, and we have to think about what that means. So to introduce this idea, I want to think about powers of 10. So if I have 10 to the first power, I have the number 10. If I have 10 to the second power, I have the number 100. If I have 10 to the third power, I have 10 times 10 times 10, which is 1,000. And I'm doing this with tens because they're so easy to do, because we could actually do 10 to the 10th, and even without having done all of these in the middle, 10 to the 10th has 10 zeros. So we would do 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and so we could fill all of this in between if we wanted to, but we're actually more concerned now with what happens the other direction. What does it mean for 10 to be to the 0 power? What does it mean for 10 to be to the negative 1? So let's look at what our pattern is here. If I have 1,000, and then I have 100, and then I have 10, each of these are going down by a 0. And so if we follow that pattern and try to fill in what 10 to the 0 power is, we would take off a 0 from 10, and that would give us 1. And as it turns out, 10 to the 0 power is the number 1. And in fact, anything to the 0 power is the number 1. So filling in our chart, 2 to the 0 is 1, and x to the 0 is 1. No matter what we have, if it's to the 0 power, it's 1. So then let's go a step further and say, well, what happens whenever I try to go past 1? Because I don't have any more zeros to take away. The other way of thinking of this was that it's like we divided by 10 to get each of these numbers, if we're looking for a pattern, because 10 divided by 10 gives us 1. 100 divided by 10 gave us 10. So to fill in 10 to the negative 1, I would do 1 divided by 10, which is 1/10. Or if I wanted to write that as a decimal, that would be 0.1. And then if I wanted to think about 10 to the negative 2, I would say, what is 1/10 divided by 10? And I would need to flip my second fraction to actually make that happen. So that would give me 1/100th, which is the same as 0.01. And so you can see that by looking at these powers of 10, we're actually kind of defining what our place values are, because this is a 10th, either as a fraction or a decimal. This is a 100th. The next one would be a 1,000th, and so on. So all this is to say that what negative exponents actually are telling us is that we have a fraction. And so what we're going to do is, if I have 4 to the negative 2, I want to think of that like the 4 to the negative 2 is going to So here's how we deal with negative exponents. We actually move them. We say, well, if 10 to the negative first is really 1/10, and 10 to the negative second is really 1 over 100, which is 1 over 10 squared, what I can do is I can take things with negative exponents and move them to the opposite part of the fraction. So if 4 to the negative 2 is on top, I can move it down to the bottom and say that it's really 1 over 4 squared. And then because I know what 4 squared is, I can say that this is really 1 over 16. And then if it's on the bottom and it's a negative exponent, I can do the same thing. This time though, I'll move it to the top to give it a positive exponent. So what we do with negative exponents is we say, oh, that means that that's really something that's flipped from where it's at right now. And so we actually correct that by moving it and making it positive and then seeing if we can deal with it. So x to the negative a is really 1 over x to the positive a. And 1 over x to the negative a is really just x to the positive a. Because here we moved it down to give it a positive exponent, and here we moved it up to give it a positive exponent. Notice that in these bottom two boxes, the negative exponent did not make our answers negative. They are still positive. There's nothing that we can do when we're simplifying exponents that will cause our problem to change to a negative. If there's already a negative there, that's different, but nothing is going to cause us to introduce a negative into our problem in front, like right here. It's not going to be negative 1 over x to the a. That's not how that works. Exponents are their own thing. They don't affect the sign or the number that's in front of this. So those are the rules, and let's look at some examples. What we do with exponent rules as we start is we just simplify things that are given to us, and we simplify by saying, okay, on example 1a here, I have 5 to the 4th power and 5 to the 8th power, but I don't need two different places where I have a base of 5. I want to combine them so there's just one base of 5. Now, if you go back and look at our rule, this is a product of powers, so we're going to add the exponents together. 4 plus 8 is 12, so this is 5 to the 12th, just from this and this. Now, sometimes what we'll do is we'll want to write that this is 25 to the 12th. But think about it, if it had been an x that we were combining, it still ends up being an x. The same is true for numbers. If this is a 5 and this is a 5, this ends up being a 5. The base does not change whenever we add our exponents. So the same thing will happen here with 6 squared, and this is really 6 to the 1st power. So it's important that we remember that this does have an exponent. It's not 0. And that means that when I add my exponents together, I get 6 cubed. Now, both of these are really big numbers. 6 cubed isn't really that bad. It's 216. The 5 to the 12th is a huge number, and then no way that I would want to multiply those two numbers together. So typically, this is fine to leave as our answer. And in fact, our instructions say, write your answer as a power or as a product of powers, which is then telling us you don't have to actually figure out what this number is. So keep that in mind as you're working problems like this. On B, we're going to use another rule. Now we've got 7 squared to the 4th power. Now, order of operations do apply here, where we want to deal with the parentheses before we put this 7 that's on the outside of the parentheses. We want to figure out what is this when I put it together. We multiply those powers together because it's a power to a power. So this is 7 to the 8th times 7. And then we can say, okay, now I'm multiplying two things with like basis, so I can add their exponents. Remember that 7 is to the 1st power, and that makes this be 7 to the 9th. Again, is a really big number that we don't want to have to figure out. And even on both of these, if we were allowed to use a calculator, there's a chance that these numbers are too big for the calculator to give us good answers or an answer at all, maybe. So keep that in mind, that we would rather just leave it as a power or a product of powers. More simplification. So these are a little more complicated, and they combine some of our rules or make us use our rules more than once. For instance, on part A, we've got this thing inside of our parentheses that is being raised to the 4th power, and then we've got it in brackets as well, and it's being raised again to a third power. So there's two ways to approach this, and this is the start of there being more than one way to approach almost all of these problems. We could either go ahead and move the 4 and give each thing this power of 4 that's inside of our parentheses, and then do the same thing again with the 3. Or we actually can combine these exponents together first. Because if I'm going to raise to the 4th power and then raise to the 3rd power, what I'm really doing is raising everything to the 12th power. I multiply because those exponents are right next to each other. There's nothing in between them except a bracket, and that tells me to multiply them. Now what I want to do is move the 12 so that everything inside the parentheses gets the 12th power. Now, one thing that we have a habit of forgetting is that even the number needs the exponent. So it gets 2 to the 12th, and then we get n to the 12th, and then this m squared already has an exponent, so we'll have to multiply 2 times 12 and get m to the 24th. Now, a couple things that need to be clarified on this. This squared right here is only affecting m. An exponent only affects what's right next to it unless there's parentheses involved. So the 4 is applying to the whole parentheses, and the 3 is applying to the whole bracket, but the 2 is just with the m. So 2 at the beginning here had an exponent of 1, and n had an exponent of 1. And so over here, whenever I moved the 12 in, it became 2 to the 12th and n to the 12th. But the m already had an exponent, so that's why it became something different than 12, and we had to multiply. On B, we have a parentheses to the 6th power and a parentheses to the 3rd power, and they're being multiplied together. So this is where we want to use order of operations, and actually we could think of this like we're doing parentheses or exponents first, depending on how you want to think about it. So what we want to do is we want to give everything inside of our parentheses the 6th power. Now, probably the easiest way for us to deal with this is to think of -2 together and say that this is -2 to the 6th power, and this is r to the 6th power. Then we'll do the same thing with the 3 and say that this is -3 to the 3rd power, and then it ends up being r to the 6th power again. Now what happens when I do a negative number to a 6th power, which is even, is I end up with 6 negatives. And so these two cancel each other out, these two cancel each other out, these two cancel each other out. So anytime we have an even exponent, our negative goes away. Now I can figure out what 2 to the 6th power is pretty easily. 2 times 2 is 4, then 8, then 16, then 32, then 64. So I could actually go ahead and write this as 64 if I wanted to. Although the instructions tell me to leave it as a power or as a product of powers, so I'm fine to leave it as 2 to the 6th. And then -3 cubed, well, if I have a -3 3 times, it gives me a negative number, and that negative number is 27. And so what we can do is we can combine our r to the 6's and get r to the 12th. And we could also say, well, 64 times -27 is a negative number. We can even figure out what that negative number is. These are still pretty big numbers, but they're not as bad as they could be. So we could just come over here to the side and work out what this is. So this is really -1728 r to the 12th. So it just depends on your teacher as far as whether or not they want you to actually go ahead and work that out completely, or if they would rather you leave it as -2 to the 6th times 3 to the 3rd times r to the 6th. It just depends, because it's nicer to be able to write it as negative 1,728, but sometimes that just is difficult to find. So one of these two answers would be acceptable to us. And if the powers were smaller than what they ended up being, we would definitely want to work it out and figure out what the number was. Okay, so example 3 makes us start dealing with negative exponents now. So 5 to the negative third, we want to make this a positive exponent by moving it down to the bottom. So it becomes 1 over 5 cubed. And 5 cubed is something we can find. This is to evaluate the exponential expression, which means it actually wants us to find a number. So 5 cubed gives us 125. So this is 1 over 125. You guys remember 5 cubed. You do 5 times 5 times 5, so 25 times 5, which is 125. On B, we have 1/2 being raised to the negative third power. What happens with this is that both of these are going to need that negative 3. The other way of thinking about it is that the negative exponent, to make it positive, we need to flip our fraction. So we could think of this like 2 over 1 to the positive 3. Or the other way of doing it is to say 1 to the negative third and 2 to the negative third, and then moving both of these so that they get positive exponents. Either way, on the next step, we will have 2 cubed on top and 1 cubed on bottom. 2 cubed is 8, and 1 cubed is 1. So this simplifies to be 8. We can use our other rules when we have negative exponents. These are both 2's, so we want to add the exponents together. And negative 3 plus 3 is 0, so this gives us 2 to the 0. We want to figure out what 2 to the 0 is, and we know that anything to the 0 power is 1, so our answer here is 1. Finally, this one says rewrite the expression with positive exponents. And also, if we could simplify, we would want to, but A and B at least don't really have any simplifying to do. So the important thing here is to note that each of these have their own exponent that's either positive or negative, and we only want to move things that have negative exponents. So in this first example, the x squared gets to stay on top, and the y to the first gets to stay on the top because they're both positive already. Only the z gets moved down to the bottom and becomes z to the 5th on the bottom. So our answer is x squared y over z to the 5th. On B, something similar happens. This time, though, I want to take the x to the negative 1 and move it up to the top. The 2 does not move because it has its own positive exponent of 1. When I move x to the negative 1 up to the top, it becomes x to the positive 1, and I still have 2y cubed on the bottom. And just so we're clear, you don't actually need to write that positive 1, and it's technically better not to. It looks nicer, but if you leave it, most teachers will be fine with that, at least right now. And then C. Oh, this looks like a doozy. The parentheses has a lot of stuff inside that we could, deal with. Like we could give everything inside this negative 2 power and everything inside this squared, and then start combining our x's and our y's. But oh wait, the entire thing is to the 0 power. So even if I simplify everything inside of here, it's still going to be raised to the 0 power, which means my answer would be 1. So usually at some point in a chapter like this, you'll end up with some expressions like that as long as you realize that the 0 power gives you a 1, it'll make the problem simpler. So make sure you're watching out for things like that. And that's all of our video today. This is an introduction to most of the exponent rules, but there are some more exponent rules that will appear in the next